Hello, everybody. Welcome back to Math 1342. We're now going to do Chapter 5, Section 2 homework. Let's look at these. Based on a survey, assuming that 39% of customers are comfortable having drones deliver their purchases, suppose we want to find the probability that when 5 customers are randomly selected, exactly 2 of them are comfortable with drones. What is wrong with using the multiplication rule to find the probability of getting 2 customers comfortable with drones, followed by 3 customers not comfortable, as in the calculation? All right. So the probability of the second customer being comfortable with drones cannot be treated as being independent of the probability of the first by being comfortable with drones. The probability of the second customer being comfortable with drones cannot be treated as being independent. Well, why not? It is independent. There are other arrangements consisting of 2 customers who are comfortable with drones, who as 3 are not. The probability corresponding to those other arrangements should also be included in the results. Well, that's a possibility. The calculation assumes that the first 2 customers are comfortable with drones and the last 3 are not. But this arrangement is not possible. Well, again, it doesn't matter because it's multiplied, so it's commutative. The event knowledge 3 times 5 is the same thing as 5 times 3. They both equal 15, so it doesn't matter how those are arranged. The event that a customer is comfortable with drones is not mutually exclusive with the event that the customer is not. It is mutually exclusive. One person doesn't influence the other. So the only one that even half right is B. There could be other things you're saying. Okay, so I don't want valuable stuff being sent by drones or anything like that. Or what are the insurance possibilities? Based on the survey, assume that 28% of the customers are comfortable having drones delivered their purchases. Suppose that we want to find the probability that when 6 customers are randomly selected, exactly 3 of them are comfortable with the delivery of drones. Identify N, X, P, and Q. N is the total number of items being surveyed. So how many we have? So we have 6 customers. So N is 6. Now, out of 6, how many we're going to examine? 3 of those. The probability P is probably a success. They're comfortable, so that success is 28%, which is 0.28 or 28%. Type integer or decimal. Okay, do not round. Okay, so you want a decimal. So then if that's 1 minus P, that's what Q equals. So Q equals 1 minus 0.28. Q equals 0.72. Right? Now let's look at this. Determine whether the given procedure results in a binomial distribution. If it is not binomial, identify the requirements. Remember, to be binomial, it has to satisfy 4 conditions. To be binomial. First, we have to have a fixed number of trials or events. They have to be independent. In other words, one cannot influence another. Since it's binomial, we have to have exactly 2 categories that our solutions can reach, either yes or no, true, false, on, off, because it is binomial. And the success of each trial is the same, or the probability of success of the outcomes. So these are the four. Now let's look at these. Is there a fixed number of trials? Yeah, they had 50 men. So it's 50 trials. Are they independent? Yeah, they're each taking a shower separately and washing each other's hairs. Exactly 2 categories? Yeah, it's either they experience burning or they don't. The success of each trial, yeah, so the person can either feel it's burning or it's not. So anything says no is wrong. So yes. Yes, because there are more than 2 possible outcomes. That's not right, because it has to be exactly 2 possible outcomes. So let's see, because all 4 requirements are met. Number 4. Get that there. Determine whether a given procedure results in a binomial distribution or a distribution that can be treated as binomial. If the procedure is not binomial, identify at least one requirement that is not satisfied. The Y-sort method of sex selection, developed by Genetics and IVF Institute, was designed to increase the likelihood that a baby will be a boy. When 90 couples, okay, that's fixed number of trials, use Q-sort method of give birth to 90 babies, the sex of the baby is recorded. They're independent because each person is giving a birth of their own child, so it's not they're not depending on the other ones. There's either going to be a boy or girl, so it's the third condition. And the success, well, you can easily tell if it's a boy or girl. So the answer is yes, it is a distribution. It satisfies the probability, the procedure satisfied all the criteria for binomial distribution. No, it has to be yes, so that's the only one. All right. Now we're going to look at what's called binomial distribution. We'll start using tables in this chapter and the next chapters. Assuming that a procedure yields a binomial distribution with n equals 2 trials, and a probability of success is 0.30. Use a binomial probability table to find the probability that the number of successes is exactly 1. So we're doing exactly 1. The way you read this table, when you get a little bit closer, because it's a pretty small table. So the first thing you have to do is find n. N is the outer numbers here. Starts with 2, 3, 4. It goes all the way down to 8. Anything larger than 8, we can't use this table. Okay, so we had n equals 2. Our x's was 1. So we, in this box at this row. So we look at our probability. It says 0.03. 0.03 is there. So in this column, in this row, the answer is 0.420. So that's how we use the binomial chart. So the answer is 0.420. Number 6. Assume that random guesses are made on seven multiple choice questions on an SAT test, so that n equals 7 trials. It's fixed. Good. Each probability of success correct or incorrect. So that's only two possibilities. They're independent because no questions don't depend on each other, and you have the same chance of getting a right answer in all of them. So each with a probability of success by 0.4 or 40% chance of getting it right. Find the indicated probability for the number of correct answers. Find the probability that the number of correct answers is fewer than 4. So fewer than 4 means it could be 0, 1, 2, or 3. So that's what we have to look at. We have to look at the probability of 0, the probability of 1, the probability of 2, and the probability of 3. And then we have to add those together. Okay, so what do we have here? We have our n is 7, x is 0, 1, 2, and 3, and the probability is 0.4 or 40%. All right, so let's look at these. Let's go to this table. We have 7 here. So we have 0, 1, 2, 3. We have to go through these possibilities. Now 40 is right here. So keep on going down, 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 down. So I'll mark this line. So we want 0, 1, 2, and 3. Those are the numbers we want to add together. So that's P of 0 is 0.028. P of 1 is 0.131. P of 2 is 0.261. And P of 3 is 0.290. So if I add all these together, point 0.028, 0.131, 0.261, 0.290, and 10, 10, 21, it's 0.710. Round to 4 decimal places as needed. Well, the table only gives us 3 decimal places. I don't know about that. Find out. But that's what I'm using the table for. Number 8. Or number 7. That's number 6. Okay. Assume the hybridization experiments, so you're looking at hybrids of each, whatever object you're looking for, are conducted with peas having the property that for offsprings, there is a 0.75 probability that a pea has green pods. Okay, assume that the offsprings peas are randomly selected in a group of 38. Okay, is it binomial? Is there a fixed number of trials? Yeah, 38 of them. Are the H independent? Yes, because one P pod is not going to influence another. There's only two possible outcomes. It's either yes or no, it's green. And the success is the same. Its success is the same as 0.75 for green and 0.25 for not green. So we have green is 0.75. The probability that we have n equals 38. The mean, since it's binomial distribution, the mean is n times p. N is 38. The p is 0.75. Q is 0.25. So 38 times 0.75 is 28.5. And the standard deviation is the square root of NPQ. So we have 38 times 0.75 times 0.25. And the square root of all that. And we want one decimal place. So the answer is 267. So it becomes 27. Now, use the range rule of thumb to find the value separating the results that are significantly low and significantly high. Okay, so remember that's the mean plus or minus 2 standard deviations. That's the range rule of thumb. So here's significantly low and significantly high. So we have the mean, which is 28.5. The mean is 28.5 minus and then plus. But remember, here's the mean. So here's 2 standard deviations that way and 2 standard deviations that way. So we subtract going back. So times 2, we get 5.4. $28.5 minus 5.4 is 23.1. So 23.1. 33.9 is the high. The first is a result of 7 P's with green pods a result of significantly low? Why or why not? Well, we had 28.5 here. That's our mean. 2 standard deviations is 33.9. So anything out here is significantly high. And this is minus 2 standard deviations, which gives us at 23.1. So anything below there is significantly low. 7 is way over here. So it is significantly low because 7 green pods is less than our 23.1, our lower bound. And number 8. If a procedure meets all the conditions for binomial distribution, except the number of trials is not fixed. If it's not fixed, if it's binomial, and it's not fixed, then we use the geometric distribution. Probably getting the first success on the X trial is given by P of X equals the probability of success 1 minus the probability of success X minus 1, where X is the X trial, where P is the probability of success for any one trial. Subjects are randomly selected for a health survey. The probability of someone is a universal donor, group O, and group RH negative is, so the probability is 0.12. Find the probability that the first subject to be a universal donor is the 5th person. So X equals 5. So we have here the probability of the 5th donor is 0.12. 1 minus 0.12, 5 minus 1. 1 minus 0.12 is 0.88. 5 minus 1 is 4. 0.88 to the 4th times that gives us 0.719. I think that was 8. So it's 0.720. 0.720. 0.0720. Okay, good everybody. I hope that helped.